Hopefully you got a chance to try exercises 7.7 and 7.8. I thought, in case they were tough, I thought I would kind of just remind you a quick summary of the types of things that we do when we do the study. So we always create our hypotheses, and those are the exact same no matter which case. So notice we kind of had two different ways of attacking the problem, the 7.4 way and the 7.5 way, but they were both almost the same. So in 7.4, we attacked the problem, or in both sections we did our hypotheses the same. The difference is in 7.4, we wrote everything with the z variable, and over here we wrote things with the t variable. And over here we use sigma for the population standard deviation, and here we use s for the sample standard deviation. And then we found our p-values the exact same way, and we found our p-values the exact same way, except when we have a z distribution, we use the normal button with mu equals 0 and sigma equals 1. When we have a t distribution, we use the t button with degrees of freedom equal to n minus 1. And then we either reject or fail to reject. So we follow the exact same process, but one of the first things we need to ask when we start a problem is, which side are we on? Are we dealing with z's and normals? We're dealing with t's and a t distribution. The big clue that's going to let you know which one we're in is whether or not we know the sigma value. Sigma is the standard deviation for the whole population. If that's told to you, if you're given it, then you know you're in this column. If your n is large enough, if you have a really big n value, then it turns out that the difference between sigma and s is so tiny you can actually choose either column and it will be okay. But if sigma is unknown, and especially if it's unknown without an n value, then you're in this column. So really, I would just totally make my judgment based on, do I know what sigma is or do I not know what sigma is? And if I do, then I can use this formula, and if I don't, then I have to use this formula. Okay, let's tackle 7.7 to 7.8, and hopefully you did these right, and we're able to get the correct answer, and then you'll feel well equipped for doing your take-home quiz. All right. 7.7, a car dealership knows that it sells on average 5 cars a day with a standard deviation of 2.25. It begins a new ad campaign and finds that it sells 5.3 cars per day over the next 30 days. With the significance of alpha equal to 0.05, would you say the advertising has helped boost sales? So we're doing a hypothesis test. The question is, which column are we in? Well, if you look carefully, it has the standard deviation of 2.25. Is that a population or a sample standard deviation? And the answer is, well, it says we know that this is what happens normally. It doesn't say this is what happened during the 30 days. It says this is what happens normally. So that means we're in this column. So we're in the left-hand column. We're doing a z distribution, and we're talking about a normal distribution. Okay, so since we're in that case, we're ready to start our problem. Let's write our hypotheses first. Okay, so if nothing's going on with the ad campaign's not having any sort of impact on sales, then we know that they should sell 5 cars a day. So our H naught is 5. All right, so what's our alternative hypothesis? If the ad campaign is boosting sales, then that means that the sales have gone bigger. So it means that our mu is greater than 5. So we're doing an H naught of 5, mu equal to 5, and our alternative is that it's greater than 5. At this point, we can see right away that it's a right-tailed test. And we also, because of our conversation earlier, know that we're going to have a z distribution. So let's find our test statistic next. Our test statistic is z equals x bar minus mu divided by sigma over the square root of n. And so I start plugging those in. I read my problem carefully. X bar is the average for the sample, and the sample was the 30 days that the ad campaign ran. And so that is 5.3 is that average on that sample. Mu is always the number from our hypothesis, so we're comparing the 5.3 to the number 5. Sigma is the population standard deviation. That population standard deviation was the 2.25 that we talked about just a moment ago. So we put the 2.25 in here, and we divide by the square root of n. N is how many experiments. Well, think of each day that you sell cars as an experiment. So that means we've got 30 days for experiments. Okay, so these are the numbers that we want to plug in. and try them out. Again, always be careful when you plug these in. I find it really easy for students to get off on these numbers. Just make sure that you get all your parentheses and everything correct. Okay, I got 0.73 for my answer. Z equals 0.73. Let's see, does that feel about right? Okay, yeah, that seems believable, I guess. Okay, yeah, that seems all right. So 0.73 was what I got for my answer. All right, so now that we have that, we're ready to start attacking. We're ready to move on to the next part. So we always kind of follow the same process as we go through it. Our process always goes hypotheses first, test statistic second, and then the next thing we'll move into is our p-value. So p-value is our next thing. And now that we're ready to start tackling our p-value, we know from above that we need to be doing a right-tailed test. And so we know that our picture is going to look like this. Our picture is going to have our distribution. We're going to put 0.73 in our distribution, and we're going to be finding that probability to the right because it's a right-tailed test. So what is our p-value going to be? Well, to get our p-value, we need to pull up our app or calculator or Excel. And I need to go to the normal distribution. So let's scroll down. There's normal. I need to make sure it's 0 and 1. And then over here for x, I'm going to put that value that I had. So 0.73 is going to go in there. And hit enter. And I want greater than. That's good because my pictures are greater than. Notice my pictures match up. And so it looks like my answer is 0.232 is what I got for my p-value. Okay, so we always kind of follow the same basic pattern. We got our hypothesis, our test statistic, our p-value, and now the last thing that we're going to do is come to a conclusion. And our conclusion here, we had alpha equal to 0.05, so we're going to compare this p-value to 0.05. And notice a p of 0.23, we're looking for really small p's in order to reject. 23% is not a really small percentage, so we're never going to reject with this. But to say it more specifically, our p is greater than 0.05, so we fail to reject H naught. What does that mean about our sales? What does that mean for this car dealership? It means there's not evidence of increased sales. So sorry car dealership, we don't have enough evidence that your ad campaign is working. Doesn't mean you have to stop it, but I wouldn't go and change everything you do based on the last 30 days. Okay, so let's come and let's now tackle 7.8 and see how it goes. So in 7.8 we have another car dealership. It also sells 5 cars a day, and it too begins a new ad campaign and finds over the next 7 days it sells 6.14 cars with a sample standard deviation of 1.35. Can we say that this advertising helped boost sales? So let's start the problem by thinking. Let's start by kind of thinking through the same set of issues. First, sorry, I hope you got a chance to try this. If, for example, you struggled on that first problem, but maybe you learned some things, it might not be a bad time to pause and go try this second problem. The more you can do these independently without me, the better you're doing. Okay, so what's our first step? Our first step is hypothesis. As we look at this problem, our hypothesis is going to be the exact same, and that is if nothing is going on with these cars, then our mean is equal to 5. They're selling 5 cars. But if our sales is working, if we're getting improved sales, then that means we're going to be greater than 5. So we can see right now that we're doing a right tail test. We need to ask, are we going to be using T or Z distribution? Which one is it going to be? And to do this, I'm going to come back to my page that I had here and ask my question, do I know what sigma is, or do I not know what sigma is. Do I have a big sample or do I not have a big sample? And as I look at this problem, notice I only have 7 days and that's small, and I'm told the standard deviation is 1.35, but notice it says sample standard deviation. So that 1.35 is an S, it's not a sigma. So that means we're in this column. So we're in the right-hand column, we're using a T statistic, and we're using T when we do our calculation in our app. So the next thing I'm going to do is test statistic. And to do my test statistic, I'm going to use T equals x bar minus mu divided by S over the square root of n. And let's plug all these things in and see how they go. And so x bar for my problem, that's how much they sold over the next few days, and that was the 6.14. That's how much they sold during the 7 days we're testing. Mu is the average from the 5, so mu is 5. S is the sample standard deviation, and notice I put those words there so you could see them pretty clearly. And N is how many tests. Notice we had 7 days, so think of each day as a test. And it was 7 days. Well, yeah, so 7 days. So notice this is the square root of 7. So let's plug all those in and see what we get for T. Sorry for the delay. There we go. I got 2.23 as my number here. 2.23. Oh, well, let's go ahead and add the 4. Okay, so that's what I got for my statistics. So now I'm ready to move along and try to find my p-value. So again, we follow the same 4 steps: hypothesis, test statistic, p-value. And my p-value, just like the last problem, is going to be right-tailed. So that means I'm going to put my number here, and I'm going to look for that right-hand side for my p-value. So let's come back to our app and see if we can calculate what p is. Notice I'm on my normal. I want to switch it, so I want my t distribution. My degrees of freedom are 1 minus 7, so my degrees of freedom are 6. I'm now going to put my 2.234 right here and hit enter. Let's check my picture. Oh, good. So it is shading the correct side. It all looks really good. And so 0.033 is what I've got for my p-value. P-value of 0.033. So notice I used my t distribution over here, and I used degrees of freedom equal to 6. So this is my p-value. So now the last thing that I'm ready to do is come up with a conclusion. And my conclusion, I'm doing alpha is 0.05. And so what I'm trying to do now is say, this is a small number. Is it small enough for me to say that something significant happened? Well, I compare my 0.03 to 0.05. Yes, p is smaller than that. So I can do something. I can reject H naught, and I can draw a conclusion for my sales. So notice that p is less than alpha. So that means we reject H naught. And what does that mean practically? Practically, that means that that sales have increased. Of course, we don't know 100% the sales have increased, but all the evidence points to sales increasing. So if this car dealership said, hey, is our advertising working? I would say, yeah, the odds of you selling this many cars just by coincidence was only 3%. So there's really a lot of evidence that the sales have helped and that the advertising has boosted your sales. All right, so that ends those examples. Hopefully this is making sense. Hopefully those hypothesis tests are making sense. You're going to need to be really good at this. So spend time on the homework. Come see me in study hall hours. Get really good at hypothesis tests. This ends the material that's going to be on the first take-home quiz. So expect sometime towards the end of this week, maybe at the beginning of next week. So expect pretty soon for me to have posted a take-home quiz for you to do some problems connected to confidence intervals, hypothesis tests, and some of the things we did right before. All right. Well, thank you very much, and come see me when you have questions.